Okay, for these notes, we are going to solve multi-step equations using inverse operations, and we're going to justify our steps in algebraic proof. So first of all, inverse operations are two operations that undo each other. You've been doing this for a long time. You know that if you have addition in an equation, you undo addition with subtraction. So addition and subtraction are inverse operations. Similarly, multiplication and division are inverse operations. So we'll be using those. The other thing we need to say is that there are some important properties in algebra that allow us to solve equations for a variable. So we've got the addition property of equality, subtraction property of equality, combining like terms. You've heard of all of these probably. I just wanted you to have a list so that you know how they are all spelled and you can look at it. But we are going to use these properties to justify our steps in what we call an algebraic proof. Okay, so this is how it works. So our algebraic proof is going to start with a given, which is just the equation that we're given to solve. So that first step, the justification, is always given. So when I look at my equation here, I see that I have like terms. I have 7x. I'm on the eraser. Okay, 7x, and I have a negative 3x. So if I take my 7x's and I subtract 3 of those x's, I get 4x. And then I still have a negative 8. That's this right here, right? Oops, I kind of botched that. That's supposed to be an 8. All right, I'm giving up on the 8. I'll just write it down here. And it still equals 24. And we were able to combine the 7x and the negative 3x because of the combining like terms property. Like, oh, I should have written smaller. We'll make it work. Okay, combine like terms. Okay, next, we know we have to get rid of that negative 8 before we're getting rid of the 4. So we are going to add 8 to both sides. So the thing that allows us to add 8 to both sides is going to be our addition property of equality. So these cancel, right? And we get 4x and 24 and 8 make, what is that? 32. Okay, and again, we were allowed to do that, to add the 8 to both sides because of the addition property of equality. You may abbreviate that as POE. All right, last thing. We need to undo the multiplication. And we undo multiplication by 4 by dividing by 4. Right? And if we do it to one side, we have to do it to the other side. That gives us x equals 8. So the property that lets us divide both sides by 4 is the division POE, property of equality. And that's our algebraic proof. We're done. See, not so bad. All right, look at this one. Again, first step is given to us. We don't have to do anything on that one. When I look at this, I see that there is a 1/4 that is a close friend of the W and a +5 that's going to leave early. So we're going to send the +5 home by subtracting 5 from both sides. That's a 5. So what property is it that allows us to subtract 5 from both sides? Well, that'll be the subtraction property of equality. Subtraction. Running out of room. Okay. So I'm canceling my 5 and negative 5. That makes 0. And I'm left with 1 over 4w equals, what is that, negative 7? Okay, the other day we did a whole bunch like this. When I have a 4 on the bottom, what I need is 4 over 4 to make a 1, right? So I already have the 4 on the bottom. I need to multiply by a 4 on the top to get my 4 over 4. If I multiply one side by 4, I have to do it to the other side. Okay, the 4 over 4 makes a 1. I'm left with w equals negative 28. And multiplying both sides by 4 is legal because of the multiplication property of equality. The multiplication property of equality is going to be one of our best friends for getting rid of fractions. That's going to be your go-to property for getting rid of fractions. Just wait. All right, that one's done. Ta-da. All right, number 3. The only one we haven't talked about yet is the distributive property. So here we have parentheses. The b plus 4 is in parentheses. So I have a negative 3 that I'm going to distribute like so. So that's going to give me 5b minus 3b. Okay, negative 3 times positive 4 is negative 12 equals 28. So I distributed a negative 3 using the distributive property. Distributive property. Okay. Now, when I look at my green step, I see that I have 5 b's and negative 3 b's. Those are like terms. So I can subtract my 3 b's from my 5 b's, and that gives me 2b minus 12 is 28. Okay, so I combined my like terms, my b's. So my justification is combined like terms. Okay. Next, I'm going to get rid of a negative 12. So in order to get rid of a negative 12, I undo that subtraction by adding 12 to both sides. These cancel, and I get 2b equals, numbers. Okay, 8 and 2 make it 10. Carry the 1. 1 and 2 and 1, that's 4. Okay, so what allowed me to add that 12 to both sides? Well, that is the addition property of equality. Last but not least, I need to get rid of the 2, the coefficient, for my b. So I'm going to divide both sides by that 2. And I get b equals 20. What allowed me to divide both sides by 2? Well, the division property of equality. Okay, my computer froze, sorry. All right, I don't know how to turn the page. Oh no.